Hello everyone. In the previous session, we discussed what is principal component analysis and need of principal component analysis. And in short, also we have discussed what is the Python implementation of this principal component analysis. So in short, I will repeat here and we will see here the demonstration for this principal component analysis method. So as we discussed in the previous session here, like your other languages here also we need to import the required packages. So here is the package sklearn.decomposition where my PCA class is defined. Right, so the method for or the syntax for importing this package is from sklearn.decomposition import PCA. After importing required package, we here create the object of that inbuilt class. So here PCA is my variable or object variable where we are creating with the help of capital PCA here, right? So capital PCA is the inbuilt method and here number of components we need to pass as a parameter. So n underscore components is my parameter, that is inbuilt parameter where we need to mention here the best value of the principal components, right? Then after creating the object, we can use this fit function to run the PCA algorithm. Right. So PCA dot fit function will run the PCA algorithm to find the here eigenvectors and eigenvalues. Right. So this method will return these eigenvectors and eigenvalue in this fit variable. So X is my data set here. For this X data set, this PCA will return the eigenvalues and eigenvectors. Then if you want to display this variance actually represents the eigenvalues, right? So eigenvalues are nothing but the variance in the features, right? So that we can display with the help of this inbuilt parameters explain underscore variance underscore ratio underscore. So this syntax is actually inbuilt syntax, so do not you can't change here the name of this parameter, right? So if you make mistake here, spelling mistake, there will be error. So this function print function will display here the eigenvalues. So for my X data set 0.92 and 0.05 are the eigenvalues. Then if you want to print the components, principal components, my eigenvectors represents the principal components. So here with the help of this component underscore parameter, you can display the eigenvectors, right? So fit dot components underscore will return you the eigenvectors. So this print function will display these two eigenvectors, right? So if my data set is a two-dimensional data set, here you will get the two principal components. So these are my values of the principal component. Now we will see the demonstration for this. So here I have started my Jupyter notebook. So here, one by one, first with the mathematical functions, inbuilt function, we will see the implementation of this principal component analysis method, and then using scikit-learn library also we will see the implementation. So here is the demonstration. So step by step we will see. So like here we need to import all the required packages. So if you execute this, so what parameters I'm importing here? So all the parameters, those are required to perform different mathematical operations. So NumPy library is required. Then we need to import the mean from this NumPy library. Then covariance method, COV is the covariance method, which is again defined under the NumPy library, and EIG, that stands for eigen, right, is the inbuilt method defined under the NumPy.linalg linear algebra library. Right, you know that the principal component analysis is based on the linear algebra. So if you run this method, right, right? There is no error. So we have imported here all the required parameters. Then you can define your data set, right? So my data set is in the matrix form here. So see, I have created one array of two-dimensional data set, right? So np.array 1, 2, 3, 4, 5, 6, right? And you can print here a, so you will see these are the two dimensions in my data set, right? So, and there are 3 rows in my matrix, right? So my matrix is 3 by 2 matrix here. The next, I want to find the mean matrix, right? I want to find the mean matrix. So now step by step with mathematics, we are discussing here the PCA component analysis. So if you see, the mean of this first column is 3 and mean of this second column is 4. So we have calculated here what mean values of this A matrix, right? So next step is to find the covariance matrix. So before going to calculate here the covariance matrix, we are finding the difference matrix, right? So, you know, we always required the difference between the data point and the your mean value. So we are subtracting this A matrix where my original data is contained from the M. So M is my main matrix. So if you display C, you will get this difference matrix. So these values represent what? The difference of my data point from its mean value, right? Then next is covariance matrix. So here we can use the COV method as we discussed here. Before going to find this covariance matrix, here I have transposed the matrix, right? So this COV is the inbuilt library that we have imported, which is defined under the NumPy library, right? So CO is the inbuilt method where we are passing the difference matrix, right? C is the difference matrix that we have calculated here. That so my COV function will return the covariance of this C matrix. So if you display this matrix, you will get the 2 by 2 matrix because my data set contains here 2 dimensions. And you know, whenever there are 2 dimensions or 2 attributes, then you get the 2 by 2 square matrix. Always your covariance matrix will be square matrix. Now, once you have calculated the covariance matrix, the next step is what? To find the eigenvalues and eigenvectors. Right, so again, we will use your ready-made function of calculating these eigenvalues and eigenvectors, right, which is defined under the NumPy library. Right, so here is the inbuilt function EIG that we have imported here. See, NumPy dot linear algebra import EIG. So this EIG inbuilt method we are using, and what matrix we are passing here, that is covariance matrix, this V matrix, right? So this eigen method will return the eigenvalues and eigenvectors in the variables defined by the user. So these are the user defined variables, right? You know, in the Python, we can mention the multiple variable names by giving comma in the single line, right? So values is the variable to fetch the eigenvalues written by this eigen method, and vector is the variable that we are using to store the eigenvectors written by this IGV. Now I want to display these vectors and values. So here we are using the print function, right? So if you execute these commands, you will get here the eigenvalues and eigenvectors. So first we have displayed here vectors. So these are my 2 vectors, right? And these are the values, right? So these values are my eigenvalues, right? So 8 is the first eigenvalues and second is the eigenvalue, right? So if you observe second value is 0 value, means there is a no variance in the second column feature, right? So we can ignore this feature actually. as we discussed, we only select the principal components. Those are providing the more information. So more information means more variance, right? That we discussed in the salary example. So if you observe here, my second feature is having zero variance, means what? That second feature is not providing the variety of data. There is no variance, right? And that's why this principal component is not important for the analysis, so we can ignore this principal component. So when you will generate the your final matrix, right, by multiplying this principal component with the my data, original data, right, so you will get the reduced representation of your data. So by ignoring this the second value, right, you will get here the reduced representation of the data. I hope student you are clear with this, right? See, now I want to convert my original data into the reduced representation. So what is the steps required here? You can multiply your original data into the, my original data is in the C matrix, right? My original data is in the C matrix, right? That we are multiplying with the eigenvectors. Here again I am repeating, student, eigenvectors are nothing but the principal components, right? So eigenvectors, right, represent the principal components. And also we have discussed that second eigenvector is not important here, right? In this matrix, second eigenvector is not providing information because this eigenvalue is 0, right? So here if you display this reduced represent, now we are using the eigenvector, both the eigenvectors here, right? Because we have not uh, taken only the one row, so otherwise you will get the reduced representation here. So if you run this, my reduced representation is only one component. If you observe this, a second column has become 0 here, right? So this is my reduced representation of the original data. You can ignore here second column because it is 0, completely 0, not providing any information. I hope student you are clear with this. Now we will discuss the alternative method. Alternative method by using this scikit-learn code. So what is my alternative method here? This is my alternative method. Here we can import the library. Here we can import first the PCA method. Now we are executing alternative method. Alternative method using scikit-learn library. Okay. So here you can, from sklearn.decomposition, you can import PCA inbuilt class. So if you run this, right, there is no error. Then here you can create the object of this. So number of components is depend on your user, right? So you need to find out here the best uh, value of the number of component that is part of your survey, right? So by trying different values of this number of components, you can first find out what is the optimal value of this component, like your elbow method. Then you can pass here, right? So now I have created object of this. So there is no error, right? So now PCA is the variable we have created here, right? Then I want to fit the model here. Now my data set is in what? Which variable that is A matrix, right? Here we have created the array A, right? So now I want to pass this A array here, right? So instead of X, I'm passing A, right? Now I want to fit the model. So if you execute this, you will get the no error because all we have successfully executed this feed function, means my PCA algorithm. Now it is time to display my eigenvalues and eigenvector, right? So I want to print here what eigenvalues and eigenvector, and that we will compare with the values we have created using the previous method, that is using maths. So if you observe student, here we have obtained this principle because here only one difference is there. Here we have transposed the matrix, right? And that's why we are getting these vectors. So 0.7 minus 0.7, 0.7 here 0.7. So same vectors we are getting here 0.7, 0.7 minus 0.7, 0.7. Here 1 is the eigenvalue we are getting. Yes, why we are getting here 1? Because here we have get it instead of the original matrix, we have passed here we are getting 8 because instead of passing the A value, here we have passed the actually C matrix. C is nothing but the difference matrix, and that's why instead of here we are passing the difference matrix, but here we are passing the original matrix, and that's why my eigenvalue is 1 here. I hope student you are clear with this execution. Thank you.